Einen wunderschönen guten Freitagmorgen wünsche ich Ihnen. Mein Name ist Andreas Schlemmer von der Boston. Ich möchte Sie ganz herzlich zu unserem Webinar begrüßen. Heute zur unsere virtuelle Tech Update Webinar-Serie zu dem Thema Manipulating Data in an Artificial Intelligent World. Wir werden heute mal so ein bisschen das Thema AI ein wenig anders angehen. Also es ist natürlich in aller Munde, man spricht darüber, man nutzt es inzwischen schon sehr, sehr häufig in Form von ChatGPT, von Microsoft Copilot ist jetzt einer derjenigen, der es auch ziemlich stark nachzieht in diesem Markt. Aber man spricht natürlich auch viel über Nvidia, über Supermicro, machen es auch die Aktienkurse bedingt natürlich machen. Aber wir haben auch heute eine andere Sichtweise, und zwar die Sichtweise von der Micron. Und hier geht es auch darum, wie letztendlich die Daten auch als Voraussetzung für AI natürlich fungieren und dadurch natürlich auch nochmal eine ganz andere Sichtweise betrachtet wird. Wie müssen diese Daten gehalten werden, gespeichert werden oder auch dann letztendlich auch verfügbar gemacht werden. Und hierzu wird uns dann auch von Micron Esther Spanjer das Webinar näher bringen. Ich möchte Sie in dem Rahmen auch gleich nochmal vorstellen. Esther, please, next slide. Und hierfür würde ich dann aber auch in Englisch übergehen. Esther ist Director Worldwide Enterprise Channel Business Development von Micron, wird das Webinar in Englisch halten, aber es ist sehr gut zu verstehen. Es ist perfekt sozusagen. Und werde dann auch gleich zu übergehen. Ich hatte mich ja schon vorgestellt, Andreas Schlemmer, und bin verantwortlich bei der Boston für das Product Marketing in dem Raum Deutschland, Österreich und Schweiz. And now I will switch over to English. There's just one thing. So if you have any questions, please do not hesitate. You can send it over to with the questions in written form, please. We will answer all the questions in the Q&A session after the webinar, and you will get, of course, all the presentation materials, the recording of the webinar after we have finished everything, so we get the information latest, I guess, on Monday. And don't hesitate if you have any questions. Feel free, use the chat functions for it. And after the webinar, we will answer all the questions. So many thanks. Many thanks also to you, Esther, that you are supporting us here with this webinar with the point of view of Micron, how AI and data works together. And I will pass over to you.
Okay, thank you so much, Andreas. I really appreciate the opportunity, as always, to continue to work together and to share, what we can bring and provide to the world in terms of the Micron product. So, good afternoon, everybody, or sorry, good morning. It's still for everybody. I already want it to be afternoon, so the weekend starts closer. My name is Esther Spanjer. I am with Micron already for 4 years. I have been within the flash and the memory industry for my entire career. And what I will talk about today really is when you're looking at a data center and enabling the hardware infrastructure in your data center to run all these new AI models. What do you need to do from a storage and memory perspective? What are the things that you need to think about, and you can find ways to optimize it? So that really is the core of what I'm going to talk about. And starting off with really, when you have any artificial intelligence implementation, it all starts with the data, right? We need lots and lots and lots of data in order to create the AI models, to create that learning, and to predict, eventually what a new outcome will be. Now, in order to do that, that data needs to be stored, manipulated, computed, etc. And once you're talking about a lot of data that needs to be manipulated, stored, etc., you're talking about a lot of memory and storage that you're going to need in your infrastructure. And that really is what I'm going to talk about. How do you store that data? How do you manipulate it? What is the fastest way and the most efficient way to do that? So when we're talking about AI, a few kind of definitions that we kind of I wanted to share. There is really two kind of big chunks in AI. It's called generative AI and predictive AI. Generative AI, we kind of really are used to this already when we're for example chat GTP is an example of generative AI that basically creates images, text, video, etc. Whereas predictive AI is really much more looking at historical data, learning from that historical data, and then create kind of new outcomes based upon that historical data. And on this slide, Amazon product recommendations would be an example for that, but we'll talk about kind of a more implementations in a medical field where you're looking at cancer images and how a doctor can use predictive AI to use the cancer image of the patients he's working on and have that run through an AI model, which then helps him to diagnose what the severity of the cancer is and what potentially can be the correct treatment method. So that's going to be the example that we will be using throughout the course of this webinar. So why are we talking about AI? AI really is the buzzword at the moment, and it is growing very, very rapidly in the data center. According to this particular analyst TrendForce, they show that the amount of server units that are going to be AI enabled is growing at a much faster pace than the total server market is growing, 2023 and 24 and beyond, of course. And so the focus of the year and the years to come, I think, will be on AI. And specifically when we're looking at the memory and the storage associated with these servers, that is really where a lot of the talks are about, because there is going to be a lot more memory and a lot more storage that we're going to put in these AI servers in order to enable this whole new world filled with AI. And how we're going to do that, that's exactly the focus of today's presentation. So when we're looking at building a data center that is enabling artificial intelligence, there's really three key things that the hardware and the infrastructure will put emphasis on. One is we're going to need a lot of performance out of our hardware. When you're looking at AI, there's going to be a lot of data crunching that is going to happen. You gotta manipulate, calculate, do whatever it is with the data, and that needs to be done in a fast way because you have such a huge amount of data that you need to go through. So utilizing products that are very, very high performance is going to be key in that AI data center. Capacity, because again we have so much data that we need to store, manipulate, crunch. We're going to look at both high capacity storage devices as well as high capacity memory devices, and we'll talk about that throughout this presentation. And then finally, power. Whatever it is that we're going to do, we have to consider the power consumption of that solution. Data centers are taking a lot of the world's power, and are going to continue to increase to take up a big percentage of the world's power. And so optimization of that power usage is going to be highly important in any kind of decision on the hardware infrastructure and the enablement of that hardware. So throughout this presentation, again, we'll touch upon these three points to kind of share with you where from a Micron perspective we have the ability to optimize these things. So when we're looking at an artificial intelligence ecosystem, when we're talking about the data center, that really is kind of like the last piece of our AI model, if you will. when you're looking at the whole part of how do you create an AI ecosystem or model, you actually have to start at the start where you're going to capture data, right? Without lots and lots of data, there is not going to be any artificial intelligence. And so the source of your data, there is, a lot of different ways to capture the data that, you want to use. So in the example that I will be using throughout this presentation, where we're looking at images, medical images for cancer. In that case, all the medical images that are scanned from previous cancer patients will be kind of, if you will, the source or the capturing of that data. So it's that will be kind of the core or the where the data is coming from. Now, once you have all those cancer images, you're going to then need to find a way to, organize, to label those cancer images. Where was it taken? How old was the patient? At what stage was this image taken? At what detection stage, et cetera, et cetera. So there has to be you have to put almost like a metadata, onto that image, so that when the AI model starts to crunch, it can utilize all of these additional labels and understand what's going on with that data. And then the last piece, which is really where the heavy compute starts to take place, is when you are in the utilization stage. So this is where you're going to be having training and inference clusters in your data center that are going to crunch all that data, create the AI model, and then eventually, provide that to a hospital as, here is the AI model. Now you can have your doctors use that when they're putting in a new, medical image of the patient that they're treating at that moment. And so that's the focus of what we're going to look at today. I certainly don't want to underestimate all the efforts that are need to be done in the first two stages, but from a data center perspective, the heavy hitting is going to be really on that utilization stage, and that is really where I want to focus our discussion today. So when we're looking at these training and inference clusters, I kind of want to split out the difference between what is considered training and what is considered inference, because the hardware that enables these parts of your implementation will be different. So when we're talking about training, this is when you're actually building a model. So you're going to need large data sets that you're going to, input into your model to, actually, make the model learn, recognize, and, kind of look at the data so that it can create the algorithms that eventually you want to, have as your implementation. Once you have the model, then you move into the inference stage, where basically you would provide new data into that model, and then the model will use what it has learned already during the training side to provide a predictive answer, a generative answer, whatever it is going to be. So the hardware associated with the training is going to be quite different than the hardware associated with the inference. So when we're looking at the kind of implementation that we started to use as an example in this webinar, so the training piece is where you have hundreds of thousands of medical images that was captured already from other patients that you're going to have to feed into your model to create, your actual predictive AI model altogether. So that is the training piece. And then once you've created the model, the implementation of that model will be when the doctor puts in that new medical image, so that the model can now predict what the chance of cancer is for this particular patient, the severity, the type, etc. And so there's two very distinct parts of your AI implementation. Now, when you're looking at these two parts from a hardware perspective, a memory and storage perspective, the training part of your AI model will require a lot of memory and a lot of fast memory and storage, so that we can, crunch all that data, compute it, and manipulate it in whatever we need. So that will be typically a much heavier kind of server implementation, what I like to call fat servers, versus the inference piece where you already have a model, and at that point you're just inputting the new data into the model, and that model needs to then generate new data. But you can already see that the requirements on that hardware will be much more moderate than for the hardware that we would use in our training portion of this whole implementation. So let's look at the actual hardware that we would possibly use in our data center for artificial intelligence. So the servers typically that will be used, that are optimized for creating that training model, will typically be much heavier, like I call fat servers, where you have a lot of GPUs, where you have potentially CXL in there. You maybe have high bandwidth memory that are incorporated together with your GPUs, and you will have very, very high performance SSD and DRAM in there. Now, when you're looking at the server that is going to be more optimized for inference, so again, once the model is created, you will have a whole lot less GPUs typically in that server. You will have probably more moderate SSDs in there, meaning more moderate performance, maybe not as high capacity, and potentially also less capacity DRAM in there. So the overall server will just not be of a heavy hitter as the one that we see when they're optimized for training. And then at the bottom we see networked storage devices that in the past have been using hard disk drives, but in the future we're starting to see more and more implementation of SSDs, and I'll share with you the reason for that. So what I'm going to do, basically, I want to kind of jump into each of these different servers and share with you some details as to why each part of the memory and the storage in these servers, what they contribute to the overall implementation. So I want to start off with kind of like when you're looking at a server or your whole infrastructure, there's really multiple tiers of both memory and storage that you will see in the overall stack. There is near memory, main memory, expansion memory. Then the storage side, there will be cache devices, local cache devices in your server, and you will also have networked storage devices to store your data lake. So we're going to jump into each one of these. So starting off with the near memory. So this is what you hear in the news, maybe high bandwidth memory. So this is basically a chip that was created, or in this case, Micron designed it in combination with NVIDIA. It's a chip that includes both GPU as well as a lot of DRAM memory, and it sits, incredibly close to the CPU. So this is not a regular DDR5 module. This is a chip, incorporated into the same, what we call system on chip with the GPU to create, a lot of powerful compute and memory capability very, very close to the GPU. The Micron at the moment leads this market. We released this product a month ago, and in fact kind of leapfrog the competition in terms of the capability. Now, a note, this is a product that gets soldered directly onto the motherboard. So when you're buying these big training servers with lots and lots of GPUs, you will start seeing this kind of implementation already part of the motherboard of the actual server design itself. So this is not something that you can choose as a kind of, during your design time when you're choosing your server, your CPU, your components, etc. This will already be part of the motherboard itself. Sorry, the next piece that I want to briefly mention is CXL. So this is a way to expand the existing memory in your server. That would be typically a DDR5 like regular DIMM module. There is now also new technologies to expand your memory address space by putting DRAM on the PCIe bus, and that is what we call CXL, Compute Express Link. This is still kind of in its early stages. Mostly customers that we are selling to are OEM customers. It is not yet very popular in the channel, but we certainly see a very strong future for this kind of implementation as we're starting to see more and more AI, heavy AI servers coming into the market. But at the moment, this is not a product that we are actually enabling in the channel. Now, where we do see a lot of customers having interest is finding ways to optimize the caching of the server, and in this case, the Micron products that we have actually multiple Micron products, and we'll talk about that, which one makes the most sense for the different implementations. So kind of going back to, our utilize and our training and inference clusters, and, the specific Micron products that we will find in these different parts of our implementation. So if we kind of, zoom out on these different kind of servers, and we look first of all at the SSD portion of it, we will see that in these high density optimized servers, so these were the servers that were optimized for our training, we're seeing high performance NVMEs. The general purpose servers, so these were optimized for our inference portion. You will see more moderate mainstream NVMEs, and then in the remote data storage, you will start seeing hard disk drives being replaced with high capacity NVMe devices. So let's jump into each one of them individually to understand why these particular devices make the most sense. So when we're looking at these, training optimized servers, the reason you want to have a very, very high performance SSD in this kind of server is because you're going to have a lot of GPUs inside your server. And to feed these GPUs with the data as fast as possible, you're going to need a large cache and you're going to need a fast cache. And so in this case, the highest performance NVMe device would be the right choice, because the last thing you want to do is have these GPUs sit idle. GPUs in general are the most expensive part in our server, and so you want to make sure that these GPUs are utilized in the best possible way. So having a fast and large cache sitting in front of these GPUs is really what would make the most sense. From a Micron perspective, this would be our high performance 9400 NVMe SSD. Now moving on to the kind of the general purpose AI server, so the one that we use more for the inference portion of our implementation. So remember, this is again, once we've already built our model, the doctor, now wants to look at only one image of a patient, feed it into the model, and the model will then predict, what the severity of the cancer is of our patient. In that case, the hardware requirements of our server are more moderate, and these servers are typically much more configured, looking at the right balance between performance, cost, capacity, etc. There will be less GPUs inside these kind of servers because there's less data crunching happening. And so looking at a more moderate NVMe device, what we call a mainstream NVMe device, makes more sense. It still works as a caching device, but it needs to be much more cost optimized than in the previous example, where the performance and the fast and the speed of the server was the main deciding factor in that design. In this design, general purpose inference kind of server, it's really about the right balance between all of these different pieces. So a mainstream NVMe makes the most sense. And then the last piece that I kind of want to talk about is remote data storage. So why would you want to use SSDs on remote data storage? We've been using hard disk drives. Actually, let me jump to this. We've been using hard disk drives on network storage, for a long, long time. So what really is the reason to replace those hard disk drives with SSDs? Because we all know SSDs are still substantially more expensive than hard disk drives. And the core reason that it would make sense to replace your hard disk drives with SSDs is not so much the actual network storage device, but it's the feeding of the data into your AI training servers. Remember, these are these big fat servers that have lots and lots of GPUs, and the GPUs need to get that data ingestion as fast as possible so they can build that model. Now the challenge with hard disk drives is that their performance is limited because of their mechanical nature. And so when you're replacing your hard disk drives with SSDs, you're now having a much faster way to submit that data into your AI server. And again, the cost of your GPU devices in your server is typically what's going to determine the overall cost of the solution. And so your focus should be to reduce GPU idle time, because at the end of the day, that will be a better return on investment of your overall AI implementation. And so your network storage may be higher on a gigabyte, dollar per gigabyte basis, but the overall solution might actually benefit from a cost perspective because you may not need as many GPUs. So when you're looking at an implementation where you have large data lakes that need to be fed into the training model, looking at these high capacity NVMe drives may make a lot of sense, because the time it takes to ingest that data lake into the AI training server will be substantially shortened. In some of the testing that we did, we took 100 terabytes data lake, and by replacing the hard disk drives with SSDs, the training happened 4 days faster. So these are orders of magnitude different in terms of the overall AI crunching capability of your solution. And that's where it makes sense to look at SSDs versus hard disk drives. So when we look at the overall portfolio from a Micron perspective for AI servers, it really is all about NVMe. And where the NVMe sits really depends on the kind of hardware you're looking to build at that particular time. High performance NVMe really makes a lot of sense for these very GPU intensive servers. Mainstream NVMe for the more moderate servers that don't have as many GPUs and have more moderate needs. And then the high capacity NVMe for this network storage when you're starting to look at large data lakes that need to be fed into the AI training model. So moving on to the actual DRAM side of the equation in our data center. When it's about DRAM and we're looking at DRAM modules, DDR5 modules, there's really two key things that we're focusing on. That is on more and more performance and more capacity. And so what are the current trends in the DRAM market? that enable these two trends. So first of all, of course, we see more and more CPUs having more and more cores inside their CPUs in order to enable higher and higher performance. But as we're growing our core count in our CPUs, we also have to grow the bandwidth of the memory that sits behind these CPUs. So we have to keep the bandwidth of the memory to grow in parallel. And so what we're seeing is the platforms that are coming out from both Intel and AMD, this year and next. We're starting to see more and more speed on these platforms from a DRAM perspective. So Intel platform that is shipping this year in 2024 will use DDR5 modules, both 4800 speed and 5600 speed, and later this year we'll even transition to 6400 mega transfers per second. Similarly, AMD, the majority of their platforms will be 4800 speed based, and towards the end of the year they will also start releasing 5600 and 6400 based platforms. So as a memory vendor, we just need to make sure that we have the right products to actually incorporate into these platforms. And so when we're looking at the Micron portfolio, the DDR5 portfolio, we pretty much have both 4800 speed and 5600 speed available today, completely released in mass production in the different form factors, RDIMM, ECC UDIMM, and ECC SLDIMM, pretty much across all of the different capacity points. So that is certainly something that we will continue to support. We already have our 6400 products planned for the fall, which means that once the Intel and AMD platforms come out later this year, we will have the right products already available for these platforms. Now, one thing that is kind of new with DDR5 that we did not see with DDR4 is kind of like a new trend, and that is what we call hang on, I'm trying to find the right word, non-binary capacity points. So let me explain to you what I mean with that. When we are, as an industry, going to CPUs that have more and more cores because we want more and more performance, the more cores means that the memory that sits behind that core needs to have more bandwidth. So we're transitioning right from 4800 to 5600 to 6400 speed in order to enable that. But the challenge that we're starting to see is that as you're putting more and more modules behind your CPU cores, you may end up putting or paying for a lot of capacity that you're putting there as well, because you have to feed the cores with bandwidth, but you don't necessarily have to feed the cores with capacity. And so you end up in a situation where customers may have to buy a lot of modules, but they're paying for the performance, but they didn't really want to pay for the capacity. So we call that stranded capacity that you're buying because you have no other choice. So in DDR5, we came out as an industry with a solution to that, and that is what we call non-binary capacity points. So we now, as in the industry, have the ability to also provide 24, 48, and 96 gigabyte modules, so that customers, when they want more bandwidth, they can put more bandwidth, but they don't necessarily have to pay extra for capacity that they're not using. So having these kind of interim capacity points, these non-binary capacity points, allow them to really fine-tune and optimize what is the right configuration between bandwidth, capacity, the amount of cores, and of course the cost. And so it just creates an additional granularity that customers can use to optimize their configuration in however they need. The other thing that we're obviously seeing in the industry is the push to higher and higher capacities. And so 128 gigabyte DDR5 modules are very, very popular. The challenge up until today is that the two vendors that have been selling 128 gigabyte DDR5, both Samsung and Hynix are two competitors. They were very, very expensive. And the reason for that is because of the manufacturing technology that they were using. Micron is coming out in June of this year with our own 128 gigabyte, but the manufacturing that we're doing here is more simple. We basically use what we call single die packaging, which is the same technique and technology that we use in all of our other DRAM modules. So let me kind of walk you through what I mean with this. So when you're building a DRAM or an RDIMM module, the way you get to the maximum capacity of that DIMM module is by, you have a certain space of how many chips you can put on that module. So the maximum capacity per chip is really what allows you to get to the overall capacity of the module. Now, what Samsung and Hynix have been doing to date, building these 128 gigabyte modules, they basically were doing what we call 3D stacking of multiple layers of silicon inside that chip, as otherwise they wouldn't be able to get to the maximum capacity. Micron basically has developed now a new technology of silicon that basically is double that capacity of 2 layers of silicon from our competition. So we call that single die packaging. And when we use single die packaging, it is in essence the same technology that we use to build our 16 gigabyte, our 32 gigabyte, and all the other capacity points that we have. And it is a much less complicated manufacturing process that we utilize. And so the advantages of building 128 gigabyte with one layer of silicon instead of starting to stack them on top of each other, creates better performance, creates better power consumption, and creates better cost. And so when we're comparing the 128 gigabyte that Micron is releasing in June, we see when we're comparing it to the competitive solutions in the market, we use 17% less power, 17% less latency, so better performance, 24% less power, and basically 45% more density in a single layer of silicon than the previous generation. So overall, we are super excited about this 128 gigabyte because it really is enabling us to kind of leapfrog our competition. We believe that we're probably 1 to 2 quarters ahead of our competition. And if any of you have tried to buy 128 gigabyte module on the market today, you'll probably be faced with $2,000+ price tag on that. The Micron 128 gigabyte will be a substantially lower price tag compared to that. So it will create, very, very big cost savings on, a similar product, in fact, a better product from a performance and a power perspective. And so overall, when we look at the AI, hardware world, and we're looking at the storage and the memory inside of that world, the demand for more and more capacity, both on the memory and the NAND, is going to be substantial. We see, up to 8 times the amount of DRAM and up to 3 times the amount of NAND that potentially can be used inside these servers. And so it is going to be a very, very fast growing market with a lot of opportunities, I think, for all of us, but understanding the right configuration of memory and storage really will be key to find the best optimization of your cost and your ROI. And with that, I really want to thank you for your time. I hope you found it informative and educational, and I'm passing it back on to Andreas for any questions that the audience may have. Andreas?
Thank you so much. Thank you, Esther. So I think it was a really great presentation from your side, especially to see how many memory and SSD usage is for the different AI use cases. At this point of time, we do not have any questions, but I really want to mention that we also offering with our business line series now the new or latest GPU server generations, also based on our technology partner Micron. So if there are any use cases for GPU servers, we are very happy to help you, to support you, to help with the configuration. And as I said, we delivering our GPU servers together with Micron SSDs and memories. So if there's anything we can support from our side, we are very happy and very keen to do that. So I do not see any questions so far, so I think we have explained everything quite well. But as I said, I think there are some really great slides, especially to see how many SSDs you need for specific use cases versus GPU. I think that's very important to understand. And I think we need to wait for some questions, so don't hesitate. Please ask. You can send them in German, I will translate it, or you can send it in English. It's up to you. Please use therefore the chat function. And I think in the meanwhile I can do some promotions of the next events, because there are also very AI-driven things we will do so far. So on the webinar series, the next one will be at the 3rd of May. Together with Supermicro and NVIDIA, and therefore we will present to you our GPU Fenway server series, as I said, based on Micron technology as well. And then we do we need to secure the data, we need to store them. So on the 17th of May we have we show our storeware enterprise backup and recovery solution. And at 24th of May, I hope we can present the latest CPU series update from Ampere Computing. So there's coming something new. So we are very excited to promote that. And also in June, we will do a review of AMD, the latest Bergamo updates. And of course, the GPUs, the ME300 series. And that's what we do online. So I see there are no questions so far. Then I will go on. But if you do not want to meet us online or use the chance to meet us in person, you will get it. So we will be at ISC in Hamburg from the 13th of up to the through the 15th of May. I guess Easter you will be also there, right?
Hang on, which one? No, at ISC I am not planning on being there. No.
Oh, not okay. I think
I
there
don't
was
know.
a
I
chance
have
to
to
meet you
be.
there.
I'm gonna go the week after, fly to Taiwan to Computech. So.
Okay, good. Okay, then it's too much travels in a very short.
Yes.
Okay, good. Then we will have our AI forum in Switzerland. It's the first one we do there, and of course our house fair, our TID. But I'm really sure that you will attend as a speaker, Esther, at our TID again at the 11th of July. And then we will close up the year with the Biotech X in Basel. It's also very AI-driven healthcare event. So if you want to meet us there, we are highly welcome. And there are no questions so far. I think if you have any questions, please do not hesitate. Send it over to us. You have our contact details, so we can also answer the questions after the webinar. And as I said in the beginning, you will get the presentation materials, the recording of the webinar, I guess on Monday. and then you can also review the content we have created for you. And if there are any questions, please come up to us. And yeah, and I only can say thank you, Esther, for your presentation, for your support, and also to our audience that you have taken the time to attend at our webinar. I think it's in Germany or in Munich especially, we will have nice weather today, so the weekend is still coming. Prepare yourself for the weekend. Thank you, Esther. And
Okay,
I'm sure
thank you so much, Andreas.
Thank you so much. Take care. Bye bye.
All right, bye.
Thank you. Bye.